Hello, welcome back. We're on our fourth video. We're trying out this new format, 5 videos in 5 days. Hopefully it's going well for you. If not, give me feedback and we can adapt even further. All right, today's topic, mechanical advantage. We've talked about work. We've talked about power, the rate at which work is done. We've talked about machines, which are devices that change forces in order to get some work done. Now let's compare machines. How do we compare machines on the advantage that they give us? What is this thing, mechanical advantage? How do we calculate it? Here we go. Mechanical advantage is the number of times that the machine increases the output force. All right? So it's a way of measuring how effective a machine is. What advantage does it give you? How do we compare to machines? We're going to compare the number of times that the machine increases the output force. So it is a quantitative measurement. It's a number that tells us how much easier the work is to do than using a direct force. Okay, so if I just lifted it up, what's the advantage I get of using a machine to do the lifting? All right, so we've got two ideas here when we talk about mechanical advantage. There's the actual mechanical advantage. And this is that real life measurement, actual, real life, which takes into account the energy needed to overcome friction. Now, in the real world, when you've got a lot of money and sophisticated tools, you can do this. It's a ratio of the output force divided by the input force. But it's kind of difficult to measure. So we're going to settle for something a little easier to see, and that's the ideal mechanical advantage. The ideal mechanical advantage, or IMA, you're going to see that abbreviation, is the advantage of the machine without friction. We're going to use really simple machines where the effect of friction should not be that big. So this is going to look at the distance, much easier for us to measure as opposed to the force. So we take the ratio of our input distance divided by our output distance. All right? So how far do we have to exert our force on the machine? What is the distance of the machine exerting that force on whatever job we're doing? All right, so this ideal mechanical advantage, the reason we're using this is it depends only on the location of the forces. Oops, that's a typo. Depends only on the location of the forces, not on location of the forces. My bad. -1, Mr. Tamer. All right, let's look at a sample problem. Ramp. All right, woman drives a car up on the wheel ramps to perform some repairs. Maybe change oil or fix a hose. She drives a distance of 1.8 meters along the ramp to raise the car 0.3 meters. What is the IMA, the ideal mechanical advantage of those wheel ramps? All right, whenever you have a word problem, I want you to follow this format. First thing I want you to do is draw a picture. Okay, there's my ramp. I'm going to go up. Where's my mouse? I can't find my mouse. There it is. I'm going to go up 0.3 meters, but I'm going to drive a distance of 1.8 meters to get there. The ramp makes it easier than lifting the car straight up onto the jack. I'm going to drive it up. That makes it easier. Do I have to go a further distance? Yes, but it makes the job easier to do. So what's my input distance? 1.8 meters. What's my output distance? 0.3 meters. So I write down my formula. Always, when you show your work, write down the formula. Substitute into that formula. So my input distance is 1.8 meters. My output distance is 0.3 meters. I divide, the meters cancel each other out, and I get a factor of 6. The ramp makes it 6 times easier to lift the car up than doing a straight lift. That's my ideal mechanical advantage. Make sure you've got all the words written down from the slide. Write down something you heard that you don't see written. Make it a full sentence, remember, not just this one word stuff. And a question that you have. What are you curious about? Once you're done with that, flip it over, do the 2-3 pages of reading on mechanical advantage. Stop when you get to efficiency, and we'll see it in class.